Hey, let me close this because I kind of lost the link and I had to go to the syllabus to get the link. You guys have the class with Robert on Tuesday,
Tuesday, Thursday.
same time.
Yeah.
Oh, that's okay. That's where he was going yesterday. All right. All right. The only thing, I mean, we're gonna do MRP. We're gonna talk about material requirement planning today. One thing I wanted to ask regarding the assignments, I told you I'm gonna post assignment 4, right? It's available, but the questions, the details of the assignments are not. I'll make sure to post these. This one is gonna be mostly on MRP 2, right, and capital type of questions. For the other chapter, because I know if I go back in here, take a look at our schedule. Okay, so we are going to cover up to this point, and then we have, let's say, just in time, lean, push, pull, production. So these are 2 chapters of the Benton book that we're covering. Supply chain management. I can actually give you another assignment for these. So potentially increasing our practice assignment to 5, or I can incorporate some of the questions into, let's say, practice assignment 4. So practice assignment 4 can be, I can do that because I don't want to increase the number. But I already told you that the load on practice assignments may not be necessarily uniformly distributed, right? So maybe like this one may be a little heavier than the other 3. Okay, so that I'll give you guys more updates hopefully next week. And then our final exam is going to be at the last session of the class. So we'll cover all the lectures, everything, and then I'll go to the end. We are, okay, we're going to do MRP, and I want to start from this one. I gave you 2 slides. So these are actually coming from different textbooks. I want to start from this one, and then we go through Benton. The main addition here is some lot sizing techniques, like additional lot sizing techniques. It goes over a few things, just talks about those. And then we have 2 of those, least cost and uh, McLaren example, right? The methods, we have those in assignments. So I want to probably do one example on each one of those, hopefully today. If we can't finish it today, we're going to come back to this on Tuesday. One thing on the last problem that we were solving, and I told you that was something, and we didn't have time. The limit here, this is question 6 from MTS example that we did. And if you guys remember, we had 3 products, and then with demands 10, 5, 15. But then there was a condition. It says the worker or the work amount, the available capacity, basically, the labor that we have available is 40 hours per week, right? So a bit practically for this example, we can't have more than 40. So on these, we can actually break them down into 10 and 40, and it's going to appear here 10 and 40 and 10. But the good thing is that we never exceed um, we never exceed 40, which works for this one, works for this problem. So usually, I mean, if companies have information systems, usually there are some optimization techniques in place, right? So you just go and check the method that you want. All right, so and it just goes and schedule them in scheduler or scheduling or planning tool, whatever tool that they have, right? If it's a computerized tool, it usually does it for us. But for this case, this is a small one. We can always manually do it. Another thing I wanted to talk about, I just wanted to point out was in terms of the lot size, this one, every time that you place an order for this one, it's good for almost 3 weeks. So 50 units is the standard batch size, and then the demand is 15, right? So 3 point something, 3.3, right? And that would be every time that you have that, every time that you place that, it covers, as you can see, 1, 2, 3 periods later, you need to order again. And then same thing, this one is 4. So every time that you place an order, 4 weeks after, for 4 weeks, you're good. This one, every time that you place an order, you're good. 30 divided by 10, exactly 3 weeks. But since we have 60, I mean, for a while, we're good. But then at that point, after you order, every 3 weeks, you have to place the order. So if you can actually play with the schedule and make sure that they never happen at the same time and kind of spread out, you never need an additional, because that was actually one of the questions here in this one. If they do need to add capacity, right? No, we don't. I mean, if you spread it effectively, they don't really use that. All right, let's move on to MRP or and hopefully this is not, again, this is not something new to you guys. Yeah, hopefully I've covered this, the basics of this on the lab, but I'm gonna start from basic again. So really quickly, MRP, this is material requirement planning, material requirement planning. Usually the way it works, the MPS table, master production schedule, it tells us for end item, for the finished good, how many units are needed and at what point in time, right? So timing and quantity of items with independent demand. Okay, finished items, the end items that we sell. MRP actually does 2 things, primary planning and secondary planning. Primary planning for those items with independent demand, it tells us like when exactly we should release the order and when and how much, right? So whatever we have, if you guys remember, we just put MPS. We never talked about releasing of order. We never talked about the release of when and how much you need to release the orders, right? So that would be, MRP actually does that for MPS, for item and item, and then we have MRP for secondary requirement, secondary planning. So that would be for sub-assemblies and raw material, sub-assemblies and material that go into end item. So their need, the amount that we need from those, the requirements, as well as same stuff, how much we need of each one, at what point in time, and when we need to release the order. Those are the things that we're going to be, I mean, MRP is going to provide to us, right? What are the master data in a business database that are needed for this, what I just explained here, the requirements and ordering all right? So first of all, we need parts. We need parts information because we are doing this for parts, right? So part table usually includes finished item, work in progress, as well as um, raw material, right? Purchase material, whatever you purchase from your supplier. So all of them are included. All of them are included in parts table. So we need that in order to have the list of those items. Bill of material for the end item. This is important because when we want to create the secondary requirement table, we need to know for which um, child item or for which sub-assemblies and raw material, we need to create this table. We need to make the plan. And also, bill of materials, we discussed this before. There are a few things that are repetitive here on this one and the other slide. Even MPS is on this slide. But bill of material also gives us the list of items that go into one end item as well as their quantity, the respective quantities. So their quantities and the multiplier that we get from bill of material allows us to be able to calculate the gross requirement for the child item, for the items that go into one parent item for one end item. And then we need safety stock when it comes to deciding about the quantity, the size of the order, the batch size, right? We need to know the safety stock when we monitor and when we plan for on-hand inventory. We need to know the safety stock, right? Safety stock goes up. We need to maintain this safety stock, make sure that we plan for that to stay and we never go below that. Order quantity and order quantity policy is important because for items there may be different requirements. We may have items that have to be ordered in boxes, in cases, in pallets, right? And different suppliers may have different requirements when it comes to ordering. So we need to know that in advance. Lead time is important because a major part of what we do in MRP table is scheduling. And when you in MPS table, our output was how much we need and at what time. But then when we know the lead time, it allows us to say, okay, if I need this at week 10, and if it takes 3 weeks to get it, I have to order that quantity at week 7, right? So 10 minus 3, week 7. And then suppliers, customers, warehouses. So all of those things also are needed because they're going to somehow be recorded in our planning, right? So from who we're buying, where it's going to be stored, and so on and so forth, right? So I'm just going to skip some of these. A parent item is made up of its children components, its child component. And this is just an example of a product structure. The table is made up of top, leg, hardware. It's just a list, but a BOM also means quantity. So one top, let's say 4 legs, and one box of hardware. This is how it's going to look like in a parts table. So we have parts table. That's a straight list of all items that are actually existing that exist in the whole company. Right? We got the unit code and PIE required, and then the UAE, and then there are other things. You may have funds, you may have limited time, you may have even the suppliers have to about that. So all of those information, right? Stock code, stock policy, warehouse that it goes. If there are any standards for the product, we have that. If there are any measurement type, we need to have that size and so on and so forth. Okay. But this is also important. If it's a finished product or working progress, working process, um, or raw material, purchased item from suppliers, right? So that's a very important piece of information because then it determines how it's going to be fed the requirement field, right? How it's going to be fed. Does it require primary requirement planning or secondary requirement planning? Does it have an independent demand or dependent demand, and where it's coming from? So there's actually a concept of independent and versus dependent demand. So are you guys familiar with that? So items with independent demand versus items with dependent demand within the manufacturing setting. Carlos, what do you mean? Okay. Seasonal items. You're talking about end items, right? Yes. So are they independent? They have independent demand or dependent? Product that we take. Okay, so they may be dependent on something else, but I mean, in this case, what we need in the context of production planning and MRP, when we are talking about items with independent demand, these are the items that their demand doesn't depend on the demand and production of other items inside the company, right? And specifically, and more importantly, the items that are used to make this item. So these are independent in the sense that their demand is determined by people in the market, actually, by consumers, by customers who are buying these stuff. So their demand comes from outside. Whereas items with dependent demand, these are the items that the demand, the requirement, the amount that we need from them is determined by other items, right? So, for example, in this, how many tabletops we need? It depends on how many table we're going to be producing, right? That's the part that its demand, its requirement depends on its parent product in the bill of material, right? So that's a secondary item. That's a sub-assembly. That's a part that goes into another item. So we don't sell tabletop and table hardware in the market. We sell this one. So that's why this is independent. These guys are dependent. These guys are dependent on how many tables we're selling in the market. Okay. All right. A product structure, bill of materials can potentially have multiple layers, right? Multiple levels of assembly, right? So this is an example. We put stuff here and make one sub-assembly and then another sub-assembly. We assemble them and then it gives us another bigger sub-assembly, and we then put it assemble that with another assembly. So there may be multiple rounds of assembly, right? It's not like like even with cooking, it's not like you put all the ingredients in at one shot, put it at once, put it in the pot, and then start cooking, right? So sometimes you have to mix two items and then cook a little bit, and then mix the other two items outside, and then cook them together, put them together, and kind of assemble that together. So that's really what happens also in manufacturing. These are two examples Just an example on the textbook. These are multi-level freedom of sale. One thing that is important actually in production planning is actually low level coding. Look, it's a convention, we always start with the end item, we put that at level zero. Level zero, and then we increase, um, the other, increase the number of level as we go down to the bottom and get closer to the bottom. So for Y and Z, the level number is going to be zero. For A, B, C, the level is going to be, oh, sorry, for A and B, the level is going to be one. If an item appears in multiple products, an item should actually receive one code on it. I mean, for B, for example, B appears here, and appears here. So in here, 0, 1, 0, 1, 2, 3. So D actually gets 2 production, that appears as 3 production, 3 actually, 3 production levels. You have different vehicle material that you have, right? You have different ranks. So level 1, level 2, level 3. Okay, but I said each part gets only one level. That level is going to be the lowest number available. So 1, 2, or 3, this one. 3, the lowest, I mean, when I say lowest number, I'm talking about the higher level. Right? Three is going to be, and that determines the order that the ML is going to be calculated. So for D, we're going to wait after we do Z and Y. Wait, let me actually write it here. So Z and Y are in level 1, are in level 0 as end item. Zero, 1, 2, 3, 4. 0, Y, and Z. Level 1, A and B. How about C? C appears in level 1 and 2, so C goes here. How about D? Level 3. How about E? 1, 2, 3, that's E. How about F? 2. How about G? 3. So now, when I create an MRT table, I'm going to start with Y and Z. And then based on Y and Z, I can create A and B. Doesn't matter which one. Because first, so in one level, they're independent from each other. And then once I have Y, Z, A, Z, then I can actually make an MRT table for C, F, D, D, and E, right? So we don't, if C appears multiple times in different level, or D appears in that in 3 levels, I don't do an MRT table 3 times. I just put it at the lowest level possible, and then wait until I complete the MRT table for the other one, until I get to the level that the lowest level that is, and then I just do that one time. Okay, this is called low level coding, right? So we code an item, we give an item, assign an item, the lowest code in the hierarchy, and we always put end items in level. Goes into product structure if we just reverse this, right? Instead of having top item on, having item, base item on top, if we just switch it and put, let's say for E, as a raw material, where does E go? E goes to C. Two E's go into one C. E goes, I have that. E goes. This is the multi-level derivation chart. Right? C goes to D. How many C's goes to one D? Two. How many C's go into one D? C. How many D's then go to Y? How many D's go to one? One, two, three. One Y. Okay. So for each D, how many E's do I need? For each D, how many E's do I need? Four. Two E's go into one C, two C's go into one D. So each D requires 3 times 2 E. Am I right? Yeah. So each C is like this. C is this. This is C. Another C is this. This is C. Okay. Each D is made out of 3 C's. So now, when you put them together, this would be this would be D. Okay, they go B. But when you assemble 2 C's together, you make one D. And these C's made up of 3 E's, right? I'm just focusing on. So for each D you require 4. But I mean, usually we don't do this. We go from top. So for each Y, how many E's do I need? For each Y, how many E's? That's here. For each Y, how many E's is there? Yeah, so for each one, we need to do it, because E appears in the 2 times, right? Okay, so we go from Y to E from this range, from this graph, we go from Y to E from this A, okay? Y, for each Y, we need 2 A. Each A is made up of 1 E, right? I mean, there are other things, but each A requires 1 E. So how many E's go to one Y from this point? 1 times 2, right? 2 for this one, 2 E's go to 1 Y 2 A. And then 2 E's go into 1 C. 2 C's go into 1 B. And 1 B go into 1 Y. So 2 times 2 times 1, 4 E's go into Y through, B through this line. With 4 plus C. 4, 6. Like, I mean, they're screwed, but, some speed go on this one, some speed goes on this one, 4 goes on this one, total 6. Or there's light or other spots. But yeah, so it's important because we're gonna have bill of material and we have to figure out how many items are gonna go into one. Because later when we create table for the children, we need to know how many items go into one unit of their parent, the main parent. Okay, I'm gonna move on, and then this is multi-level. Single level would be actually if we have to just show the immediate children. So if I say Y is made up of 2 A's and 1 B, without explaining what else go into the sub-assembly A, that would be a single level bill of material, right? So that's it. Summarize BOM for product Y is if I don't show the sequence, if I don't show actually that, but instead I just say Y, field of material for Y, we have 1A, 1B, like 1E, right? 4F, 1B. Sometimes, I mean, summarize, and they only show this one, but it's not really helpful. Only show the lowest level in a production in different banks. These are usually raw items, the items that we need. But when I say raw items, I mean the raw material. I'm talking about items that we purchase. They may not be raw product, but for the company, they're considered raw because they haven't done anything to them yet. They just buy them from suppliers. Okay. All right, moving on. So where used chart. Where used also is the reverse, right? Where used chart is just the item on top goes. We instead of actually having the end item on top, we just go inverse, right? We just put the item, the sub items, the raw material on top, and then go inverse, right? So, and then we have definitely single level, multi-level, and so on and so forth. Another thing here is product variant. Product variant, I mean, when it comes to tables, we talked about this before in this chapter, right? The super bill and like different ways, right? We talked about set covering, super bill approach, to how to handle that. But in here, I mean, first of all, what are variants? Variants are products that are practically the same, right? In order to actually be able to compete in the market, in order to be able to go to different base of customers and attracting to buy our product, sometimes we have to have different options, right? Let's say these are also possible product. We have to give them some options. Sometimes we have for batteries, for example, battery size, different wheel size for an automobile. There can be actually specific features inside, leather seats, like heating seat, like a few options that are available, right? So these options make different variants. Even the color on the paint, right? That actually makes a different variant. For how companies handle these, because I mean, each variant is in fact a new product, a different product, a separate product. And if you want to actually consider in the store, bill of material, all those planning information for each item, you're going to require a lot of data, a lot of storage for keeping those information. Companies, in a lot of cases, try to come up with interesting ideas and innovative ideas to not actually need that many. Right? So if the variants are static, meaning that they're not changing, we don't have a lot of variants, and we know that they're not going to change, and it's kind of under control, right? In those cases, they actually this is one possibility, right? So they just make this, they keep everything else. For the finished item, they say, okay, we have two variants, and it's because of two variants, two versions of part E, which actually makes it two different sub-assemblies A, two different versions of sub-assembly A, and two different versions of or two variants of X, right? Everything else being the same, these are all common, and these only these three, so 3 times 2, we allow these to be recorded differently. As you can see here in the list, we have X, and here, So this is an approach in the table. They actually define it as fields, right? Define each product element as a separate field. And here you have the list of items. Notice right? This is actually a structured table. And you have the upper limit, upper part and lower part, parent and child, right? So in a lot of cases, we don't have, when you work in the ERP system, you can require like this, get a query, you're gonna get a table view of recipe, right? It tells you, and this is one way that they handle static, instead of having two separate tables, one for X1, one for X2, they still have one table, but they just create three tables and then they record quantities. Later, when planning comes and they ask for the quantity, it just goes to the table, and when you have the query, you always go to the same table, but filter for that column. For that column, for the rows that have value in that column, and then you see the field of the tree, right? Another thing, so this is summarized POM. I just talked about that. So that's basically the same thing, putting them in different columns. We talked about super build. We talked about other things, lead time, how long it takes. Yield also is important for products. If the number of items that we get, if the reliability is not 100%, this actually is an important item, important piece of information here. The reason is, if yield is not 100%, and if we, for example, we need 100 units, this is actually 100 units that we need to, for example, sell or consume. Now, if you know that they're not going to be able to do it, you're not going to be able to send the 100 units. In some cases, you may have to order a little more, or if a unit, I mean, this can be sometimes, in most cases, actually kind of negotiated within the company, right? Production really knows that they're not going to be able to provide you 100%. They need to increase that a little bit. Yeah. Here is actually trying to give you a way to calculate the exact number. So if the yield is 90%, and if you're looking for 100 units, 100 correct units that pass QC, you need 112, and this is how you calculate it. 100 divided by 90, 111.11, so that would be 112. Okay. So dealing with missing data in MRP table, in anything, when it comes to planning information, if you have missing data, this is a really important challenge for production planners, for consulting companies when they want to do ERP system. This is something that in a lot of cases requires like meeting with people that know stuff and getting that information and putting it into the system, right? If it's somewhere else, you need to try to get it. You need to ask people based on their experience. There might be actually people that know where those information is recorded in the system or how you can find them. Worst case scenario, you just ask an expert for those values, somebody who has been around in the company for a long time. Okay. This is actually a little bit about the design of system, and if you want to implement a part or a part structure table, part numbers. This is looks like that is a trivial issue and not important, but a lot of companies have issues with this one. It's extremely important and has to be really seriously taken at the beginning of the ERP implementation project, right? Because later, if they define part numbers and later, the 5 years later, 6, 7 years later, they realize that okay, we're out of part numbers. Part numbers that we are not really effective, and they want to decide to change it. Everything has to change. All those databases, everything has to be addressed in that database, right? So, this is the core of everything when it comes to production plan, to invoices, part numbers appear on all the, when it comes to customers, when it comes to suppliers, when it comes to inter department transactions within the company, right? There are two purposes that they need to play, right? There are two purposes that they need to fulfill. One is the main thing actually is that they have to be unique. So that's definitely number one idea here, that they have to be unique because their primary objective is that we want to use that for identification. And for identification, we need a unique ID number, right? So that's one thing. Second thing, if it's not used by robots and machines, and people are going to read it and kind of try to get some sense out of it, we need those part codes to be also meaningful, right? In the sense that they actually can classify the product and say that, let's say what year, what model this product is it a finished product, is it a work in progress, is it raw material, what type of product, what year, what model, and then let's see, right, the serial number. So when we combine these two services, we have the 4 types of numbering. I mean, each one has a pros and cons. If we have serial numbering, it's good. The only problem that is that when you look at it, it's just a bunch of numbers. There's no way you can actually get any inside information from it. Classification numbers, these are good. But the problem with this one is that if it's just classification, they're not good for identification. So you may actually have different items with the same codes, which is really not a good idea. Compound numbers, if you have serial numbering within each class. So you have finished item, for example, work in progress. And then for finished item, you have 1 to 1,000 codes, unique codes assigned to them. And in another class, work in progress, you have 1 to 1,000, right? The only problem with this one is that you have to have the full code in order to be able to identify the product, right? Because the serial numbers are going to sometimes be the same for different products. But when you have the whole code, class plus the serial number, then you can identify. Parallel numbers, they're nice. It actually serves both purposes. And the only problem with this one is that it's going to really be long and it's time consuming, space consuming. Okay, but anyways, it's very important to plan ahead and plan for at least 15, 20 years in advance, right? So you don't want to change that. We talked about master production scheduling, master production planning. Anonymous demand and customer demand. We talked about this, anonymous or stochastic, I called it. Anonymous demand. This is like trying to push in the market. You produce with the assumption that there's going to be demand in the future. So you're producing for the customers that you haven't yet, you don't have any traction yet, right? Because the way that these items are going to be stored in the market, they're going to be stored later, and somebody's going to come and buy them. Planning for customer orders is basically make the order system to be great, get the orders and then plan for the items. And I mean, which one is better? Which one is worse? There are a lot of considerations, right? Depending on the type of product, type of company, the type of industry, level of competition, the necessity of the product, and so on and so forth. The complexity of supply chain, the complexity of the technology of production. All of these play, they're actually important factors when it comes to choosing the environment setting. So master production schedule, as we talked about, is like a computerized calculator, right? It's not just calculator, it is a system in the sense that it connects to database, gets input, calculates it, and provides that information. And it has the capacity to connect to other information systems and provide that information to other systems. We talked about available to promise before. So available to promise, MPS, and inventory, these are the items that we have in MPS table. We're not going to deal with customer orders in MRP table. The reason is for those we are doing mostly secondary requirement planning, meaning that we don't get customer orders for those. Okay. Okay. Primary and secondary requirements. We use MRP table for MPS table for our end items just to get the scheduling part done. We do MRP table for sub-assemblies and raw materials for secondary requirement plan. Discuss this, but that's basically the same thing. Okay. The process, the MRP process, it actually starts, I mean, I'll show you a table and then we talk about it. But it always starts with demand estimation, right? Gross requirement plan. For end items, their gross requirement comes from the market. It's either based on a forecasting model or based on, let's say, a rough cut on aggregate planning, right? We talked about aggregate planning, we talked about sales and operations planning. A lot of companies actually do a rough cut, say, we want to go with 20%, 30%, 50%, for example, of our capacity assigned to different product types. So it's that. But then for children items, it's going to be their gross requirement of their parents multiplied by the BOM quantity, bill of material quantity. We have the gross requirement, then net requirement. The difference between gross requirement and net requirement is that net requirement is the actual gross requirement is how much in total you need, like the customer wants or the production unit required, right? This would be basically how much you have to send out. Next requirement tells you how many units, what's the net amount of units that you have to produce or you have to plan for in order to be able to meet those requirements. In a lot of cases, net requirement is less than those requirements. Reason we may have inventory on. So if gross requirement is 100 units, so you have 20 units on here, I mean leftover from previous cycle. 100 units is the gross is what the other department wants as a customer. You have 20 units in stock. So the net requirement for me right now that I have to pay is 190. So if I can produce 80 units, I shouldn't produce 100 units. Because if I produce 100, I will carry over that 20 units that yesterday and that's gonna be extra cost. Unless that's actually part of my safety stock cost, right? So I have to be, the net requirement, actually, sometimes I have backward, gross requirement for this period is 100 units, but I have a backward of 20 units. So the net requirement in this period is 20 from that period plus 100, so 120. In order to be able to meet the requirements of this period. Order time about planning, once I know, okay, I need 80 units to complete. But, I'm going to go 80 units, maybe yes, maybe not, right? Depending on, other responsibilities, like, if it's production timing, if the, internal unit have to see what is requirement is. Sometimes actually we have cost factors. Once you set up, you have to create the machine for one cycle, right? So, you have to, let's say, the raw materials are in gold. You can't just create a half a roll to the machine and put the other half or another. If you set up the machine, you have to have at least one roll going to the machine, right? Which can actually have a specific number of parts coming out of it. So then maybe have to be standard backstop, right? Or there may be a minimum backstop, because there is another possible quality or technical requirement. Dependent upon planning, goes and law, that's basically going to the next level, going to the production of the, going to the planning of the next items, and then forward shifting, we just go in time, right? We we plan for week one, then week two, then week three. We do forward shifting in time for each item, and then we go forward shifting in BOM. We do it for top item, then we go to next item, next item, next item. Level by level, I do this last year, based on the low level code. Okay, low level code here, and I already explained that. MRP process actually starts with MRP table with the first level, level 0 for the end items, and then we go to level 1, we go to level 2, so on and so forth. This is an example of MRP table. I mean, there are, as you can see here, 6 actually rows. There are 3 parameters that are going to be useful, that are going to be needed, at least 3. So order quantity, or batch size policy, or lot sizing policy. And then, or if there is a minimum order quantity, there's a standard order size, again, you need to know that. Then it's safety stock. Safety stock is the amount that we need to retaining our stock consistently. Lead time also is the amount of time that it takes to get that in front of the So these 6 rows requirement, like I already explained, the total amount needed from our department. Scheduled receipts and projected available. We have 2 types of receipts, scheduled receipts and planned receipts. Scheduled receipts are planned receipts that were already planned in the past. Planned receipts are the ones that we are gonna place them. We're gonna have to plan for them in the future, either right now or sometime in the future. Does that make sense? Right. So scheduled receipts are the ones that we're not gonna place the order has been released, or we're expecting them to be arrived. And we count that as inventory. We count that as items that are going to be received very soon, right? We count that as added items, count that as the what. Projected available is going to be inventory level, it's the status of state variable, right? Net requirement is, like I said, the total net amount of items that we use in satisfy the growth requirement, considering the on-hand inventory in the past, considering the stagnating fee, that would be the net requirement. And then based on the net requirement, we're gonna plan based on the net requirement and safety. So sometimes we have a net requirement that's zero, but we are sure from safety staff perspective, right? If you gotta order the plan will be received, and then plan will be released, going to be the yield is 100%, you just order exactly as needed, new year, lead time period. So that's for that. This is an table, and then what we once we do it for a product, we just go to the next level, right? Dalton, you have done this before, like MRT tables, and filled them. No, the specific this one. Okay, well, we're gonna, and then there are a few. We're gonna do a few examples. But one thing that is going to be new for Carlos and Dean is this book actually that I'm gonna show you in a few minutes. That one actually uses. We talked about these three methods: EOQ, POQ, and lot for lot, right? But there are I think 3 more techniques that it tells us. We are going to go over 2 of them hopefully today. And that's it, right? These are the ones that I want to ask you. Okay, so outcome of MRP systems is basically that this table that tells you, basically give you a nice plan, gives you a calendar, a nice plan, how much you produce, how many units you're going to get, how your inventory is going to look like, and so on and so forth. So you're kind of planning, putting everything into the calendar in terms of what you want to produce, how much you need in certain points, and so on and so forth. Okay, and then in terms of the lot sizing, there is actually this unit, this row, plan order receipts. When you want to plan for the receipt of items, I already told you, if you need 80 units at some point, you need to go and check your ordering policy. Ordering policy sometimes actually is dictated by the supplier, right? If it is your raw material, you in some cases you don't have a lot of choices, right? The company says you want to buy, you have to go with 1 pallet of size 1,000. So, and if you need 80 units, you have no choice but to buy 1 pallet. You're going to be with that unless you want to freeze it. Sometimes it's you who want to decide, right? But these are your production units, right? So if you send an order, production order to the workshop in-house, all right? In some cases, actually, you have the power to say, I want to make it. Lot for lot says, if it's possible, whenever you need the quantity, you just go exactly based on that. If you need 5 units, you order 5. You need 100 units, you order 3. So there's no real delay. You not get the order. EOQ, on the other hand, EOQ model, we can't that. EOQ model is a model with a quantity, order quantity, and minimizing total inventory cost. Inventory, holding cost, setup cost, right? And you put them together, minimize, this, very good estimate of the quantity or the quantity. Pre-order order quantity uses EOQ But it's an extension to your price. You may not get a round number, right? Um, or sometimes you actually order and EOQ, let's say, is enough for two weeks of your demand. But in a lot of cases, you may have a little bit of leftover. EOQ actually tries to get something close to EOQ, but also rounded in the sense that, let's say, after 2 weeks, you're going to consume whatever you have, and then you're going to go to level zero, where exactly 50 is safety stock level, safety level, right? So, twice to round it off, will round down, basically rounding into the or minimize the rest of the impact. Yeah. So for this one, let me actually open the next one. It's going to be very quick because already we covered a lot of things here. Okay. This is chapter 6 from Cengage book. Type of demand, independent versus dependent. Well, we just discussed that. These are independent demand. These are based on demand forecast. So their quantity comes from either a forecasting model or optimization model, or from, like I said, Rothschild planning from aggregate planning. Dependent demand, the demand always comes from the demand of their parents in the bill of materials, right? In the part structure list. MRT table, these are, like I said, computerized information system that get input from like the forecast, other things that we discussed, all the master data that we talked about, lead time, scrap information, suppliers, and so on and so forth, and then give you the plan. Okay? It's different from reorder point in the sense that, I mean, reorder points, we use those systems and replenishment model, we use those for independent models, whereas MRP mostly primarily is used for item dependent items, right? For secondary. Here is the conceptual model. So we do sales and operations planning, aggregate plan. This feeds the MPS. This provides the input for MPS. So we get the aggregate plan, do the rough cut planning, get an estimate for the end item, demand for end item. MPS actually, when it's completed, we know how many end items we need at certain point, and then bring it to MRP using the known quantities, right? Here, again, MPS, bill of material, and inventory report 5, they input they provide they actually provide inputs to MRP table, and MRP table provide primary, secondary, and inventory transaction price. Basically, it's our job, right? So input, output. Here we have the same information, lead time information, scrap, lot sizes, and so on and so forth. And then we get time, phase, requirement plans. And then these are the rows. I'll explain those on Excel again, and I give you the formula, Excel formula. Here are some examples. So this is MPS. This is actually MRP from MPS, right, for a primary, right? So if I have 470, by the way, I usually separate, like I showed you the other example on the other slide. Right? I have the net requirement, and then I have planned order receipt and a planned order release. And the reason is all of the examples that you see on this slide, safety stock is 0. So that's why net requirement becomes the quantity that you need. And especially if it's a lot for lot, you're gonna go with the order quantity, right? You're gonna, that one it doesn't appear here, but I would like to separately, clearly provided and reported, right? So if you have 475 in unit and there is a gross requirement of 400, there's going to be and no order plan here. You're gonna have a leftover of 75 units. So this one is going to be carried over to week 2 and week 3, right? In week 3, you have 75 on stock, but there is an order of 270, or there is a gross requirement of 270. You're going to be short 195. So it's going to show as the net requirement. And since the lead time is 2, we're going to release it to the earlier. And then on-hand inventory is going to be 0. Now, moving forward in week 5, nothing on stock, 375. We have a net requirement of 375. Safety stock is 0. We're going to plan, it's lot for lot. We're going to plan to get 375. When should we release the order? 2 weeks in advance, and so on and so forth. That make sense? Yes, it's the simplest case. No safety stock, nothing, lot for lot. Okay, we don't like do any computation when it comes to it. Once you get the net requirement, you can actually calculate plan order receipt. Okay, and if you have items you get for this one, and then you can calculate the children. The only point for the children is that their growth requirement is equal to bill of material quantity. Let's say for legs, it's going to be 4 times what? 4 times what on this thing? So say I have actually let's just move on, but because then how when I don't let's say 4 times this table, right? 4 times number of tables leg. Okay, how many table legs do I need for these one? 400 times 4? The gross requirement for table is okay, table leg, the gross requirement for this is going to be the number of items that I need to send to my assembly line, just so they can do their job. The assembly line, they already have like 475 tables. They in terms of the need, you didn't usually label one for leg, for table, for how about for table leg? Only 3 million table leg in the basement. And remember, for making a table, there is need a table top or a table leg and everything like that. Object, table object. We don't need any tables to be received in this one. But isn't there anything else that would really need one? Like, we're putting in an order. We're putting in an order and it takes TV to assemble. Right? So, I mean, our assumption, this is our assumption for now. We assume that it takes 2 weeks to produce this. 195 units. For this, in order to go to your assembly, these guys are gonna start working on it in this time, right? 195, they're gonna start working on it, and they're gonna finish these. So the production of cables, we're gonna start in order for them to be started, this is our assumption. We're gonna select for cooking, you need to have, we assume that you need to have all the ingredients on the table, and then you can start them. So if that's the case, then you need 195 times 4 ready here, made for this production that is gonna happen between this one and this three. You need to have everything ready by this one. That is also the safety matter, right? So you want to have everything and 3 also available at least 1. And it's gonna be 195 times 4. 780, and we need it in week 1. So you see where I'm getting this week 1? I'm getting it from here. Week 1, 3, 5, 6. 1, 3, 5, 6. That's where they appear, right? So in terms of the timing of those becoming 4% children, that's where they happen. And then the quantity, the gross requirement for those, that just determined based on their beyond quantity. All right. One seed, bags, whatever. And then you can create an article or thing. Okay. In terms of the design of MRP, time buckets should be weekly. I mean, not necessarily, but weekly is very common for companies, right? For in MRP, but it has to be. If MPS was monthly, if we went from quarterly in aggregate time to monthly for MPS, just weekly actually looks like a solid choice, right? So we just break it down and move it. But I mean, we can also have there are companies that are daily MRP, there are companies that have shift by shift, right? So or hourly. All right. Safety stock, we talked about that. It's just for items that are critical for the company, items that have variable lead time. We need safety stock. Items that have uncertain demand and uncertain lead time, or uncertain both of them, demand during lead time. If that's the case, then you gotta keep safety stock. If you don't have uncertainty in demand and uncertainty in lead time, do we need to keep safety stock? Not much, right? If you can 100% predict how much demand you're gonna have and how long it takes to get the product, you can plan ahead and try to avoid the safety stock. The problem is the reason we keep safety stock is because we have uncertainty, right? And that's why. All right, let me just go in terms of the lot sizing. So that was the thing I wanted to talk to you a little bit. I mean, before we get to that, failure factors for MRP. If you have an MRP but no one uses it, so that's clearly a failure. Especially the top managers, they have to support it. They have to ask for reports, timely reports from employees from production planning department. And then you gotta have accurate input data, right? It's garbage in, garbage out, right? So you gotta make sure that We provide good information in, feed it with good information. That way you get good accurate result. MRP table actually works best for, I mean, you have to have 99% accuracy on your inventory information. So it doesn't like fluctuations in demand, right? So you gotta, but when I say fluctuations in demand, I mean, you can have different uh, forecasts for demand, but if it wants to change from a week to another week, right, without notice, then that's a problem. So you can't really, um, it's going to be hard to use that. When it comes to lot sizing techniques, lot for lot, EOQ, POQ, I just told you a little bit about those. Least unit cost is just the rest, least unit cost, McLaren and Silver Mill and Wagner within. These are, and then dynamic programming here, dynamic programming, Wagner within WW dynamic programming. These require additional computation, right? So you can't just say this is the quantity and just calculate it and put it there. For every time, for every week, we need to make these calculations. We need to calculate and pick the right quantity, pick the right quantity. Very briefly, lot for light, whenever needed, you just order exactly equal to the amount that you need. EOQ, you calculate the EOQ, and that would serve as our standard. Here it says go with the, so this would actually serve as a minimum order quantity. But in a lot of cases, this actually serves as a standard size. So that means if you need more than whatever amount is your EOQ, you need to order 2 times EOQ, 3 times EOQ, right? So you can't just do EOQ plus 1. So you have to go 2 times EOQ plus EOQ if you need to go above. Periodic order quantity, you find the equivalent number of periods of demand to be included in a lot. And that calls, the book actually calls it TBO, equivalent number of periods that need to be included in a lot. And that's simply EOQ divided by average weekly demand. That gives you the number of weeks that you can expect. I told you, EOQ is basically EOQ with some rounding. We try to avoid having leftover at the end of 2 periods, every 2 periods. Least unit cost, we try to find we calculate, we accumulate the net requirements for successive period, and then once it usually drops, right? But then at some point it starts to peak off, and it starts to actually go back off basically. So there's going to be a minimum in terms of the unit cost. So we go with the order quantity that gives us the least amount of cost, unit cost per unit cost. Okay, so we just do that's really the policy here. And then McLaren order moment. This one actually is a very specific scenario. Instead of having this is an extension to or a different version of this one, least unit cost. Instead of actually calculating costs and telling which one gives you the least cost, because cost is also hard, right? So you don't have similar to the inventory model, right? For inventory model, the best scenario, the best case, if you want to find the best inventory quantity, is if you have this stock out cost, the shortage cost, holding costs, setup costs, all those cost elements, and then just put it into the table and calculate the total cost for different order quantity. And then you can actually find. But then in a lot of cases, we don't have those cost elements, especially for stock out cost. What do we do? A lot of companies, I mean, I think Dalton, you guys are covering it right now or sometime for the way they do it for reorder point, they don't go based on cost. The management defines a service level. So they say, let's say 95% or 90% chance of stock out, right? Or I don't know, 10 to 5% or 10% chance of stock out, and then 95% chance of being able to use it. So they actually do it based on, right, LTV. Something like this, right? So instead of that, instead of going with cost, they just say, you know what, based on experience, we know that 5% we can tolerate that, 5% stock out, we can tolerate that, but same idea happens here. So instead of actually doing costs, McLaren says calculate a target for for basically items per period, right? Cumulative items per period. And then once you get to that point, we stop and we order and then move to the next cycle and do the calculation again for future. So the target actually is calculated here. Average weekly demand times this formula, sum of TBO, we just set it EOQ divided by weekly demand, right? And then whatever number we get, if we round it down, or if it's a round number, we just go to the next number, the lower 1 unit lower than TBO, basically. We put it here and then solve it for this equation and get the target. And then we can go ahead and calculate that. Let me actually show you, go back here. So part periods, cumulative part period, we calculated part periods that go into stock, keep in their stock. So if we have net requirement of 80, 100, and 124 in period 1, 2, 3. If I order 80 units in period 1. So that's one scenario. I just only order enough for that period. Or the other alternative is if I order in period 1, I order 180, which is enough to cover week 1 and week 2 net requirement. Or I order 304, which is enough to cover period 1, period 2, period 3's net requirement. Okay, so I have 3 scenarios. But then here it says part periods for, if I order 80, my part periods are going to be 0. So cumulative part period 0. Next one, 0 plus 100. Okay, why 100? Because if I order 180 in period 1, I'm going to consume 80 during period 1. 100 is going to be carried over from period 1 to period 2, from week 1 to week 2. So that 100 is going to be part period. Okay, so that's going to be that. And 100 is less than 180. I believe this one, it doesn't say what's the calculation here. No, it doesn't say. But I believe it's like 180 something. So 100 is less than that. So we keep going. Calculate again. The next one is 348. The cumulative part period. And 124. If I order 304, 80 of it is going to be consumed. 100 of it is going to be carried over and consumed here. But 124 is going to be carried over 1 week, 2 weeks, and it's going to be consumed. 124 times 2 plus 100 times 1. If you want to part period is 348, it is above that level of 180. That's why we start on level two. What does that mean? We go with this one. That means at period one, we're gonna order 180, which is enough for period one and period two. We're gonna do an example on this one later. The other ones are gonna be a little, like a little more challenging. Silvermill, and then the dynamic programming one, WW, is gonna be really, it requires programming, right? Multiple rounds of programming. It's a dynamic programming problem. We have to basically see for different scenarios. This one requires minimizing the total relevant cost per period, and then we are similar idea. We are accumulating the period requirements, and then once it's again it keeps going down, and at some point it again takes off and goes up again. So whatever level that gives us the minimum, we're gonna start there, right? And then this one, like I said, it's a dynamic programming. It's the most complicated case, but I mean there can be computer model that use this. Nowadays, a lot of applications use heuristics. Extremely fast, hundreds of thousands of products, you can actually get the output, as you guys saw the other day, advanced planning suite. You can actually get the output within a minute or so, like a couple of minutes maximum. That's how long it takes to get. And in a lot of cases, if time is really a factor, there are there are, but because these heuristic also they have some parameters, right? So you go in the back end and change some of the parameters, um, which makes it faster, but then makes it less accurate. So you lose some accuracy, you lose some optimality degree at the cost of making it faster to get the output, right? So it's basically a trade-off. All right, and then yeah, and then the next step, which we discuss next week, is going to be MRT2, manufacturing resource planning, and eventually, when we put everything together with human resource planning and accounting system and financial system, we get to ERP system. Okay. Yeah. Okay. So we'll now let's go ahead and open practice assignment 3. Okay, like I said, for practice assignment 4, I'm gonna put questions from like MRP2, just in time, lean, and supply chain. So it covers a little, and then later, for if I teach this course again, I'll uniform it out at some level that I. But for now, that I mean, hopefully you guys understand that. I'll be 100% perfect. But let me get this one. Practice assignment 3. And I also posted an Excel file on this one. I just I'm gonna go there. Let me actually open this one and open practice because I want to show you how to get. I already showed you on this file, but I just want to take the time to show you. For example, for a child, what happens with the grocery cart? I'm going to take a few minutes of break, just go wash my hands and be back. Let's say 5 minutes. I'll be back soon. Is there any questions before I go?
No, sir.
Okay, perfect. Okay. How's your NetSuite and SAP cases going? You guys tried yet? Okay. Yeah, that's okay. Okay. You guys are doing SAP one, right? All the warehousing. Um, on, and then, I want to actually tell you, I'm gonna do this one first. Yeah. Okay, on this one. So this is the bill of material. We have X item. X item is the parent item, and then it's made up of two A's, three B's, and one C. And we got MRP table, NPS, Master Production Schedule for X, and MRP, Primary Requirement Planning for item X as well, which is the N item, and then 1, 2, 3 tables for A, B, C, the children, okay? So let's just do MPS, because we got, I mean, I know we did it last time, but let's just also do a quick practice of this. Okay, so available balance on MPS, if I have everything, if I have the forecast, customer orders, um, and the actual MPS, the available balance is super easy to calculate, right? Available balance is, what was the formula? I want to put a formula. It's always nice if you can, right? Sometimes if the formulas are complicated, so we may choose to just do the calculation, like the logical connection, and then check the logical connection, and then do the calculation, put the values. But sometimes it's easy, you just put the formula and then try. Available balance is always equal to total supply, which includes stuff that we have, we are gonna have at the beginning of period, plus stuff that we're gonna get during the period, minus all of the stuff that are going to be consumed during the period or expected to be consumed. So whenever we have customer demand and forecast on MPS, we want to make sure that we get the maximum, because if the customer order is less than forecast, that means, okay, so out of that 100, we have realized 60 of it, but we're still expecting 40 to be realized, right? But if that is above, the customer order is above forecast, that's still okay when you take the maximum formula. That means you are, so you were expecting 100, but you promised more, that's still okay. You just take the customer order, whichever is higher here. So that's it. Put the formula here for you. And then there is really nothing else. Available to promise is independent from available balance, right? I can just go ahead and, or I mean, sorry, available balance is independent from ATP. So I can calculate available balance on hand inventory independently. So week 2 is going to be 400 plus nothing minus 150. So it'll be 250. 250 plus 300, 550 minus 10, 540 is it, on hand, expected on hand. 540 minus 100, 440. 440 minus 200, 240. 240 minus 50, 190. About the space here. 190, and then next one, 190 plus 150, 340 minus 100, 240, 240 plus 3 plus 100, 340 minus nothing, 340, 340 minus 150, 190, 190 plus 400, 590 is the total supply minus 200, 390, 390 minus 150, 240, 240 plus 100, 340. And I just kept using the same formula. I just dragged the formula to the right. Okay. For available to promise, I need to order it. I need to calculate it for period 1, period 3, period 7, and period 8, and 10, and 12. Am I right? So anytime that I have an NPS, I need to calculate available to promise. And then I definitely need to calculate for period 1, regardless of if I have any NPS or not. So if this one was at period 2, then I would have done period 1, 2, 3, and so on, right? So 1 definitely, if I have, okay. If I don't, I still do it. And then after that, any period that I have an NPS, right? Expecting delivery. So, and then available promise for the next, for period 1 only, initial inventory plus, if you have any NPS, minus sum of whatever that you have already committed up to the next NPS. So then we move to period 3. Period 3 is going to be NPS. NPS minus whatever you have committed, sum of whatever you have committed up to the next NPS. For period 7, it's going to be NPS minus whatever you committed until the next period. This is 150. This is 100 minus sum of 6, 8, and 9. This one is 400 minus sum of right period 10 and 11. The customer order will be 10 and 11. For 12, it'll be 100 minus customer order at period 12. Boom, that's it. Thank you. Okay. Now, for MRP, I mean, I mean, honestly, if you have an NPS and you want to do an MRP, this NPS, whatever way that they're calculated, you just copy it over as your planned order receipts, right? Those are going to be your planned order receipts, and then you just plan for the release of orders, right? But in this case, if you notice, values is not matching the forecast. So it's a whole new thing. It's a whole different thing, this MRP, right? So I'm gonna actually decide about it. And as you can see, I highlighted them in yellow. So I'm gonna decide about planned order receipts. Okay. So in a table, first thing, I mean, the scheduled receipts, usually, there's no decision about those. They're already, it's an external factor, they're already planned, and we just, somebody puts it here in the table, right? So that's for that. For gross requirement, yes, we need to calculate it. Gross requirement is the first thing that we need to calculate. The second thing, we need the net requirement. Okay, net requirement. Then we, based on the net requirement and based on the safety stock, we decide about the order. The receipt and release of order, and then we go on calculate the end of period inventory. Okay? Lastly, order. First, gross requirement, then the order of filling. One, gross requirement. Two, like I said, schedule receipt is already filled, right? Gross requirement. Two, net requirement. Three, plan order receipt and release. Okay, I mean, it's release first and then receipt. Plan order release. And then fifth, on hand image. Projected on UH. Projected on. If it's for primary item, if it's for an N item, gross requirement already given. But for the other ones, I'm gonna have to calculate. You can see for A, B, C, the row one is also highlighted. For net requirement, what is the net requirement? By the way, this 250 may be better if I just insert another column. Call it week 0. That means this is a current week. For item X, net requirement. What is the net requirement? For week 1. So the growth requirement is 350. 350 is the growth requirement. Okay? How much production is going? If I have, in net requirement, we're usually consider inventory, right? But then when it comes to plan what the receipt, and that's why I said, I usually prefer to have three. In the example that we had on the front, there was no safety stock, but in the example that we always do, we have safety stock, right? So, and that's why I sometimes I'll find when we see some big time problems. Because we have safety stock. So the net requirement is everything that we need minus whatever that we had available at the beginning. Let me actually put this 250 here. 250 is the current limit. So the net requirement is gross requirement minus how much we need. So, sorry, how much we need total gross requirement minus how much actual physical inventory that we have in stock in week 1. So that would be this, parenthesis, this, plus this. Scheduled receipt, even though it's not here yet, it's going to be here sometime in week 1, right? So we count that as an inventory in week 1. as something that is going to be removing the active. Natural comment is either 0 or positive. It's either there is a requirement or no requirement, right? So I can't have a negative value. So just to avoid this, I put a max of 0 and that. And that makes sure that I'm not getting negative values. And if it's 0, if it's actually negative, it's return 0. Okay, so that's the formula for net. Or okay, I don't have any requirement, but do I need the order? There may be a need. If my net requirement is 0, there may be need for ordering. The requirement related to this tends to be the requirement of I build the safety stock and my order and my inventory actually drops below that, right? Then I may need to do. How do I know that? I can actually do this. I can go ahead and calculate inventory. I put the inventory formula without any file on the receipt. See what my inventory is going to be without that. And then if it drops below 100, then I go and for. Okay, so let's just put the formula for on-handing. What is the formula for on-handing? Let me actually add another row here. On-hand inventory. Inventory is going to be previous inventory plus everything that I received during this week, including scheduled receipt plus planned order received minus gross return. So if I have 240 at the beginning, and I'm going to get 240, sorry, 250 at the beginning, and I'm going to get 250 during the period, and I'm going to only consume 250 of it, I'm going to still have 250 units at the end. And that 250 is enough to cover it for my safety stock. I don't need to order, okay? So I go to the next period. Week 1, we're done, nothing to order, we're good. We move on to the next period, we go with the same order. Net requirement, I just drag to the right. Net requirement, I have 250 in stock. There's a gross requirement on 0 for these two. No requirement, I'm good for my requirement. Net requirement is 0, nothing actually. So my inventory is also gonna stay at the same level, 350. I'm good. I go to the next period. What the net requirement is gonna be for period 3? What do you think that net requirement is gonna be for? I have the gross requirement is 300. I have 250 in stock at the beginning. So how much more do I need to have? In order to be able to sell 15. Yeah, so it's gonna be 300 minus 15 minutes, it's going to be the net requirement. But then 50 units is how much I need. If I order 50 units, would that be enough? This is the time that I have to order. Would 50 be enough? I can order 50, but if I order 50, my inventory level is going to be zero. Was that causing any problem? Doing the problem? Safety stuff. So I have to keep that. So that's what's here. 100 plus 50. Right? So that's going to be the final order. Received. This is if I solve it based on lot for lot, I put 150 here. And then I update the inventory level. Inventory level is going to be 100. 100 is the safety level. We're good. All right. If this was lot for lot, I don't need to worry about anything. And if I need 150 at week 3, I need to release it in week 1 in order to get it in 2 weeks, because the lead time is 2 weeks. So just go backward in time, release it in week earlier. So week 3, I want it. Week 1, I release it. So the lead time is 2 weeks. Safety stock is 100, and that's why I added safety stock in there. In fact, whenever managed to find in highway, the amount that we need actually is going to be, and that's minimum order quantity. That's minimum order size that we need to the next quantity plus safety. Some textbooks actually add that to the way they calculate next quantity. They also consider safety stuff added stuff. They include safety stuff, consider performance stuff. So it depends on how this stuff. But anyway, if we put 150, are we good? Okay, so this was lot for lot, but here it says CBI for this quantity, right? We're doing it for 2 periods. The next requirement is 50. When it's a 2 period, I should order enough because of this period and the next period. So when I order, right, this period and next. The gross requirement in here is 0, so I don't need to add anything. It's basically I'm gonna count out. And I don't care about whether we count half, I'll see anything. So it's basically, if this is enough, so I just move on to the next period. Next requirement 0. Safety, I mean, nothing to order. Inventory is gonna stay at 100. Week 5, same thing, nothing to order. Net requirement 0. Inventory is gonna be 100. Safety stock level, we're good. Did we have anything else to say? Did I delete anything? You guys have blank? Okay, so it's basically 0. So 100 again is going to be carried over. 0 is going to be there. Okay, for week 7 now. If I have 100 units in stock, I need the net requirement is 50, and I added to the safety stock 100, so it will be 150, right? It's going to be how much we need for it. Except that I have a need for additional 100 units in the thing. So 100 plus 150, 250 in week 7. And that brings on hand inventory to 200, but then it'll come back to safety stock in 1 period after this. So every time that I place an order, I need to see that period and the next period. The net requirement for these 2 periods plus the safety. Okay, we're good for period A. Net requirement is going to be 0. I just move to period 9. Period 9, net requirement is going to be 0. There's nothing. That 100 units is going to stay on. Task unused. So week 10 now, there is a net requirement of 300. When I add the safety stuff, it's going to be 400. There is no need in the 11 next week. So the 400 is how much I need to, right? 400, release it 2 weeks earlier, and then drag inventory calculation 100. 100 is going to stay there, net requirement 0. For week 12, net requirement is going to be 0, except that if I don't add anything, my inventory is going to go down to 0. So I order 100 units. So we basically cover lot for lot and PFQ, right? PFQ, whenever we cover, and then the only thing in PFQ is the TBO, right? The equivalent number of periods. That would be BOQ divided by average weekly demand, A in the book. Okay. But EOQ itself is square root of 2B, capital B, annual demand times setup cost divided by, right, divided by holding, annual holding. And then A is, in this case, is average weekly demand, average of weekly demand. About 1 of 10 million. Average of weekly demand for this item. That's just not. So average weekly demand. And here also average weekly. Average periodic or average weekly. Average weekly demand is 109 here. But EOQ depends on the cost. Provide that for us to make it. Okay. We got this one done. And the reason I wanted to do this is because I wanted to show you how to get the because I said gross requirement is the first one. In this one, that was for what? But how about its children? Let's just do for C, because I mean we did lot for lot. We just discussed POQ, but this one actually has a standard order quantity, 250, item C, and that's a little bit. Let's just do it for C for now. Okay, so for this one, C is for every X, how many C's do I have? 1. So I just need to get planned order release of X times 1. That would define the gross requirement for C. Gross requirement for C is going to be 1 times planned order release of X. And let me also formula. Let me just drag it to the right. And Great. Okay, get gross requirement, then net requirement. Here I have 230. Net requirement, what was the formula for net requirement? Max of 0 and gross requirement minus actual stock, right? Which is the previous inventory and as well as the schedule received. That's going to give us the net requirement. You know what? I can actually, if I want, I can do this. I can do this plus safety stock. Safety stock plus gross requirement minus right safety stock plus gross requirement minus whatever that I have available. And that gives me the finance. That gives me the but I mean, I think that this textbook actually, the one that I use, doesn't do that. So net requirement is excluding safety stock. Yeah, and it's because it doesn't include. It doesn't, all of the examples that we have doesn't. But I mean, if I want to include safety stock in net requirement, it's very simple. I can just add it to the clear system. All right, but yeah, okay, so 0, do I need anything? If I add safety stock, it's 50, plus. I don't need anything, and the reason is because, I will have 80 actually in stock, and 80 is enough. I mean, let's just, no. No safety stuff. We're good. Just go ahead and calculate on-hand inventory. It'll be equal to previous inventory plus scheduled receipt plus plan order receipt minus gross requirement. And then moving to the next year, we have 0 net requirement, and then but inventory now because we have a scheduled receipt, receipt scheduled for week 2. So on-hand inventory is going to go up to 180. Let me put the formula correct. So inventory is going to go up to 180. If I just drag this all the way to week 4, nothing is going to change. Inventory is going to be carried over to the consumption. In week 5, though, the net requirement is 70. I have 180 and 250 is how much I'm going to take out. I'm short 70. And I also need to add safety stock of 50, so 120 is how much I'm short. Out of that okay, so 120 is how much I need to order, but or how much I'm short, but there is actually a standard order quantity, right? So I have to order 250. Every time that I order, I need to buy a full box of 250, right? So, and then I have to release it 1 week prior. So if I do that, inventory is going to be updated to 1 week. So week 6 and 7, the gross requirement is 0. So my net requirement is going to stay 0, and be 0. On-hand inventory is going to stay at 180, so it's going to be carried over. For week 8, we're going to be short 220 for meeting the demand. But then, yeah, so 220 plus 50. So 270 is how much I need to order. It's above 250. So how much do I order? I need 270 in order to meet in order to meet the gross requirement. I will have to take this back. How much do I add here? 500. Two boxes, right? Two cases, two batches. So it'll be 500, and I reduce it 185. The 280 is going to be projected on hand. For week 9, I just calculate net requirement 0. 280 is going to stay there. Go to the next one. On hand is, yeah, net requirement is 0. I have 180 actually in excess, which is going to be enough for safety stock. That's going to just be carried over to the end of the work. Questions? We're good, right? So you should be able to do it for product 1 and product side A and B. The only thing here is for product B, and this actually happens sometimes. We may have some accessories, some sub-assemblies, some items that go into a product, and those products are also sold in the market as well, right? So we have a work in progress that is kind of a item that is sold as an accessory, like a resale item in the market, right? So this actually item B, the gross requirement has to be calculated based on the planned order release of item A. But then if this item is also sold in the market, so this item has risks to that, dependent on A. And also sold in the market, okay? And then we have some demand, independent demand. The 2, 4, in these 5 periods, we need to add that those 50 units. Let me actually go, I will be, let's at least get the gross requirement. So we have the 50 units. I can actually add it here. So it'll be independent demand. It'll be period 250, period 450, period 550, period 850, period 1050. So only for this one, the gross requirement is going to be item B, by the way, is how many B's do we have in 1X? 3. So it's going to be plan order release of X 150 times 3 plus the independent limit. And then we just. Okay, let's take a look at the problems from MRT, and then the rest you should be able to do it. Let's take a look at some of these problems. Let's see if we find anything interesting here. To complete the following MRT record for item A, this is actually it's very similar to what we just did. Lead time 2, lot size is 350, and then we got the gross requirement. We have the schedule receipts. We can project it on hand at the beginning is 120. We can easily calculate the next requirement and plan for the releases. So I'm gonna skip this one. For the other one, we have two products, and then we have their bill of material with their quantities, respective quantities. And then we also have for each sub-assembly or each item that goes into the final product, we have their lead time, right? This one actually says determine when orders should be released for item V and W. Okay, V and W. For V and W, we need U, and for U's, we need R and judgment weekend. And for judgment weekend is independent. For R is itself is dependent on extreme combat, right? So we need bit 1, 2, 3, 4, 5, 6. 6 M of the table in order to get to the answer of the question. But I mean, this one can take a little bit of time, and it's practically very similar to this one, right? Except that the tables are going to look differently. But the key here, especially because you have multiple levels, the key is what? What do we do before we actually start solving? We need to define the level, right? Based on the low level code. Because again, V appears in level 0, 1, 2. V appears in level 0, 1, 2, and 3. So for V, we have to wait until both U and until U is captured, right? I can't just do it in here, or in here. Sorry, in here, I have to do it one time, right, for each one, and I have to wait. I have to assign them with their lowest level code, and then wait for them until they appear. All of their parents are already calculated. That's the whole idea. And okay, I'm gonna skip this one. That's okay with you guys. You should be able to solve it. Question 3. We don't have much time. I don't wanna take on a large question here. This one actually is also multi-product item for all of these items. Okay, so it kind of describes the BOM, right? The bill of material. And then for each item on the bill of material, it provides a table that gives us lead time and scheduled receipts, how much, and then there's a order schedule, and then initial on hand, as well as the standard lot size. If you have, whenever it says 1, lot size of 1, multiplies with 1, that would be lot for lot, right? So you can order whatever you want. But whenever it says, for example, 25, it has to be multiplies of 25. So it'll be 0, 25, 50, 75, etc. Okay, I'm gonna skip this one for now. Okay, let's see. Question But again, this one, you need to, let me see, for question 3. Okay, it says several partially assembled because of the depressed economic condition. Component parts are assembled in batch runs. At any given time, each level of production has several partially assembled components. Production of the valve begins with the base. Base is placed and secured in housing. A ball bearing or okay, so that's what I said. It just gives you a description of bill of material, and then you need to create a table, and then it tells you the order side, the oil leak valve, which is gonna happen in period 10, and it's gonna the order requirement for this one is the gross requirement is 400. So you're gonna start from this one, but then you need to also create a description of the production. You need to also create a bill of material for lead valve with the quantities, right? So the quantities that it says, I mean, sometimes it says, let's say here, it says 2 sets of brackets are screwed on and the oil leak valve is checked before shipping, right? So 2 sets, I mean, so you have the quantity and you also have the sequence. So it kind of gives you the level by level instruction for making 1 unit of oil leak valve, right? Is there any part of this that you want me to try? Good, yeah. The bill of material, and then based on that, so it becomes exactly similar to the previous one, except that it's a little bit. I was thinking maybe doing this part, like trying to get the bill of material, but I mean, it should be pretty straightforward. You have the list here, and then here it tells you the order that they get added to each other, right? And then they make up eventually 1 unit of oil. Question 4. Let's see here. Sandy's Cabinet Company uses MRP to schedule its production due to the current recession. The need to cut costs. They targeted the inventory investment area for cost reduction. The company does not want to reduce its customer service level in the process. Demand and inventory for a standard 2-drawer file cabinet are given in the following table. Complete an MRP matrix for the cabinet using 1. No lot sizing, minimum of 200, multiplied with 175 lot sizing. Which lot sizing rule do you recommend? We have ordering costs, holding costs, lead time, and beginning units. So this one actually, I want to do so this is question 4. Let's just do this one. Let's get this. The reason I'm looking at this is because we have some cost element, and I can actually calculate EOQ as an example. Okay. We have gross requirement. We want to be set 5. Gross requirement 145, 165, 155, 135, 170. The question asks for no lot sizing, basically lot for lot, minimum of 200 multiplied by 175. But I'm going to go ahead and calculate, and then it's asked which rule do you recommend. So the costs are given in order to be able to calculate the cost and compare them based on the cost. Um, estimates, right? So, but I'm gonna also do EOQ. So EOQ is square root of 2 times annual demand. So annual demand is not, let me actually do those first. So elements that we need for EOQ, we need annual demand, D. We need setup costs or ordering costs, S. We also need holding costs. But if I put annual demand, my holding cost also needs to be annual, right? I can actually do this instead of doing that. I can, all I need to make sure is to have holding costs and demand in the same time period, right? If instead of annual, if I have monthly holding costs and monthly demand, that's perfect. If I have weekly demand and weekly holding costs, that still works, right? So instead of annual demand, I just put weekly and here holding costs per week. How about that? And I can just leave those. So weekly demand, I don't have it here. So I'm just gonna use average weekly demand. Great job. I know that we don't have a lot of data points here, but since the numbers don't fluctuate, hopefully that estimates a good one. Setup cost is given for ordering cost, $100. Holding cost per week is $1 per cabinet per week. So EOQ is SQRT of 2 times D times setup cost divided by 8. And I can round it, right? One second. And it's actually, as you can see, multiplied of 175 lot sizing. It's item C here. A C actually yields the funds. Right? And just calculate it here is 175. So this is lot for lot, minimum of 200, it says minimum of 200. So 210, 205 is fine. 270 is fine, but 195 is not fine, right? Anything about multiplier of 175, basically EOQ quantity. So let's just do EOQ now. Let's just do lot for lot and EOQ and then do cost calculation. We have like 10 minutes. Gross requirement, and then what else? Scheduled receipt. Do we have any scheduled receipt? Put it on hand, rejected on hand. What else? It's requirement. Plan order received, release. Okay. There's really nothing, right? It doesn't say anything about the schedule received, nothing. Okay. Beginning inventory 150. Okay, that's good. Beginning inventory is 150. Net requirement also, right? for the formula here too. Okay. Net requirement for the first week, net requirement is max of 0 and gross requirement minus planned order, I don't know, projected on hand for that. And we don't have any safety stock requirements, so I just go based on that. So net requirement is 0, no order required. We just move on. We just calculate inventory and move on. Inventory is going to be on hand plus scheduled receipt plus planned order receipts minus gross requirement. So 5 is going to be on hand. Next period, net requirement is going to be now 160 because we have 5 only and 165 is needed. The 160. This is actually, we're going lot for lot. That's what I want to do. So 160, so I'm going to order 160 and I'm going to release it. Lead time was 1 period. So I release it 1 period before. Updating inventory, I will have an inventory of 0. And I will keep actually having an inventory of 0 because it's lot for lot. And I only order as much as needed. So the only purpose is actually not to have an inventory left over. That's the benefit of lot. Okay. Next period, net requirement is 155. I'm gonna order 155. I'm gonna release it 150. 1 period before inventory is going to be 0. Next period, net requirement 135. Order 135. Release it 1 week before and move on. Next period, net requirement 170. How much we order? 170. Release it 1 period before. That's it. Let's do EOQ now. EOQ of 175. I just get this one. See, put it here. I only need to keep everything is good. The only thing I need to remove is planned order receipts, right? Let me actually remove these also because I can always write the formula. So we did it for lot for lot. For the and 5. In the first three, I don't need the net requirement is 0. I don't need order. Right? And if I don't order, the on-hand inventory is going to be at 2. So if I go to the next period, there's a net requirement of 160, which requires ordering. And since EOQ is 175, just order 175 and release it 1 week 5. So my inventory now is going to be 115, 175 minus 160. 15 is going to be leftover. Next period, next requirement is going to be 155 minus 15, 140. And then I need to order. How much do I order? Enough multiplies of EOQ to cover that, and that would be 175. Okay, I update the inventory information. Inventory is going to be 35. Go to the next period. Next requirement is going to be 100. I need to order 175. Release it 1 period before. Updating inventory info 75. Again, net requirement is going to be 95. Order 175. That's EOQ 175. one last thing before you guys go, is we need to compare the cost, right? Ordering cost, holding cost, total cost of inventory. The ordering cost is how many times we order using lot for lot. If let's just include this one too. Count if of this range, if it's positive, how many times we ordered multiplied by the ordering cost of 100. So 4 times order multiplied by 100, so it'll be 400. Holding cost is going to be end of period inventories times holding costs per week, right? So in total, we carried 5 units only for 1 week. 5 times 1, that'll be $5. And if I add these two, it gives me the total cost of inventory. 405. Okay. And if I just do this for EOQ, I'm gonna get EOQ value, I mean cost estimate for EOQ. And in fact, it's 610 because ordering cost, I mean, EOQ didn't help me in minimizing the ordering cost or making it smaller. So I still have to pay $400. But it actually now I'm left with a lot of other stuff left over at the end of periods, which I have to pay the holding cost. The holding cost goes up significantly compared to last one. So 610 is the total cost. I would assume if you go with 200, you're going to end up with worse case. It's 200 is not good. But in this case, if you use POQ of 2, I'm positive that it's going to save you a lot of money because EOQ is 175, average demand is 154. So you would like to have like T is going to be 2, about 2, right? So if you say 2 and holding cost is actually ordering cost is a lot on different. So it's going to save you a little bit of money. All right, guys, that's it for tonight. You may want to add QOQ for yourself. Try this one. On next week, I think I'm gonna do another one because I didn't get the time, get the chance and time to go over least estimated cost, and then here question. These are okay. This one, MON and LUC. LUC, least unit cost, and MON. I just want to show you one example of these. Next time I think we're gonna do question 10 or 11 or some other questions that have these, just so I can show you how to calculate those a little more dynamic basis. Okay. So that's it. Let me actually share screen.